Hello students. Today in the numerical session we will do a numerical on the maximum tension. This is the part number 3 of numerical problem on belt drive and rope drive. So let's start with the numerical problem. So this is the numerical problem in which it is say that a rope drive is to be designed to transmit 700 kilowatt power from a pulley of 120 centimeter diameter running at 300 rpm. The angle of lap, that is the angle of contact, is 150 degree. The 150 degree it is given in the degree, so we will convert it into radian, and the coefficient of friction is 0.3. The mass of the rope is 1.5 kg per meter. This mass is the not exactly the mass, it is the mass per unit length, because the unit say that kg per meter, so it is 1.5 kg per meter. The safe pull, what is the safe pull means? Pull means tensile force. Tensile force will contribute for the pulling. So it is the safe pull means maximum pull can be the maximum value of the tension, which is known as the safe pull, in each rope is 2000 newton. So determine the number of ropes required for and neglecting and considering centrifugal tension. So there is given that the neglecting and considering. So first is neglecting means without centrifugal, and second case is for using centrifugal tension. So what will be the number of ropes? So if I say so just analyze this question, that determine the number of ropes. Means if one rope is required to transmit a power of small x, okay, so sorry, if it is required that just take it in other way, that if it is required to transmit a power of 100 watt, okay, but there is a rope which is only eligible for transmit a power of, which is only eligible for the to fulfill the requirement of transmitting the power of only 10 watt. So how many ropes are required? Total required is 100, and one rope is transmit only 10 watt power. So how many ropes are required? Total 10. How it will come? 100 upon 10, that is equals to 10 ropes are required to transmit the total power, that is 100. So at the same in the same way we will solve this problem. So we are going to find the power transmitted by the single rope, okay, and we have the total power of 700 kilowatt. So we will divide 700 kilowatt by the power transmitted by single rope, okay. So now we are going to solve this problem. So first of all we have to write what are the given datas for from this problem. So total power, capital P, I'm writing this 700 kilowatt, that is 700,000 watt. The pulley diameter of the power source pulley means a rope drive is to be designed to transmit 700 kilowatt power from a pulley, okay. So now you can see this is the question for the rope drive, but we have studied in the theory lectures in that if the rope drive is there, there is a groove angle, but in the question there is no groove angle is given, so we can assume that the rope is on the flat pulley, okay. This rope is rounded over there, this pulley, that so there will be a slipping condition, but we are not considering that slipping condition to fall down left or right. This rope will fall down, but it is not given that it is grooved pulley, okay. So because there is no angle is given for the groove angle, so we just consider that this pulley is going to be contact with this. So now just see that this pulley is rotating with a speed of 300 rpm. The angle of contact there is 150 degree, that is in radian 2.617, and mu is 0.3, and mass is given 1.5 kg per meter, okay. So for safe, so just this is very important, this is very important. Safe pull in each rope is 2000 newton, means one rope can withstand maximum load of 2000 newton. After this value, if the pulling force is more than 2000, the rope will be break down. So this is the maximum value. So this maximum pulling force is known as the maximum allowable tension, and maximum allowable tension is denoted by T max, that is equals to 2000 Newton, and the maximum tension in the belt or rope drive is known as T1 or T2. It will known as T1. Okay. So number of ropes required, that is small n. This is the question. So now the total power equals to the power produced by the or transmitted by the one rope multiplied by number of rope. Is it clear? So now if small p is the power transmitted with one rope only. So total power, capital P is the total power that is given 700 kilowatt. As groove angle is not given in the problem, therefore it will not be in the picture. So groove angle is not going to be in the picture, so we are not going to use the groove angle for this type of problem. So now the case one is not considering centrifugal tension. So I'm not going to use the formula for the centrifugal tension, because in the formula for the centrifugal tension the T1 will be equal to T1 plus Tc. So but not centrifugal tension, so T1 by T2 equals to e raised power mu theta. Mu is given, theta is given, so we will have T1, and T2 is not given, but T1 is given because it is given that the maximum pulling force, that is T1, that is T max, that is 2000 Newton. So we can find this T2 value. So T2 will come out will be 911.87 Newton. So the power for single rope, that is small p, that is equals to the difference of the tensions, that is T1 minus T2 multiplied by R omega. R1 is the D1 by T2, and omega 1 equals to 2 pi N1 by 60. This is N1. If we are taking this 1 for the first pulley, then this speed is also for the first pulley. So D1 N1, D1 by 2, because R1 equals to D1 by 2, and omega 1 equals to 2 pi N1 by 60. So we will have the value for the single rope. The power developed or transmitted by the single rope is 20,510.76 watt, but required total power is 700,000 watt. So how many number of ropes are required? That is capital P upon small p, because capital P equals to n into p, so small n equals to capital P upon p. So the value is 34.128 ropes. But we can see this is the total ropes, 34 ropes is required, and plus this much 0.128 rope. This type of rope is not the valid values. So we know that the power is required more or equal to 700,000. So how can we achieve this? If we use only 34 ropes, then we cannot provide 700,000 watt of the power. So we are going to use one more rope for the power transmission. So we will have more power, but it will not less than 700 kilowatt. So we will use the next value, 34 plus 1, that is 35. Okay. The case 2 is considering centrifugal tension. So what will be the answer for this? So I'm not we have this topic in the centrifugal tension lecture. In the previous lectures we have seen that if there is a centrifugal tension, there is no change in the power. Have you seen this? You may have seen this topic, in which if we put the TC, this maximum tension is the T1 plus TC, and minimum tension is T2 plus TC, and TC is cancelled out. This TC will be cancelled out. Okay, so T1 minus T2, that is R1 omega 1. So the power will not change. If small p is not change, this will not change. So how this, and this is constant, this is also not change, so this will also not be changed. So the number of ropes required, if the centrifugal tension is considered, then the number of ropes are required is also 35 for the case number 2. So I have written this answer. Therefore, so you also have to write this, you are not going to write this like this. So you have to write this lines, this statement, that therefore there will not be any change in the power with single rope by considering centrifugal tension, and hence the number of ropes required to transmit 700 kilowatt power will also be the same, that is 35 number of ropes. So thank you for the listening my lecture for numerical problems. So we'll do gear drive, and we'll do the numerical on the gear drive in the next upcoming video lectures. Thank you, and subscribe my channel.